So for purposes of the video, we factored this denominator, then we multiplied through by x plus 1, x plus 2 every term, canceled out in the denominators. That's the whole point, to get rid of the denominators and to be left with a solvable equation. This one happened to come out to be quadratic, so we factored it. All right, number 5. Got some options here. Nobody cares how you do it as long as you're not cheating. So add 4. The first thing you always want to do, no matter how you're going to do the problem, is get the absolute value by itself. We call that isolating the absolute value. Get it by itself. And you got a couple of different options. What pops into your head? What is your gut thought when you look at this problem?
2 different problems.
You can break it into 2 different problems. And when you break it into 2 different problems, you'll say 3x minus 1 equals 6. So in other words, just exactly what it says. Or what's the second one? 3x minus 1 equals negative 6. Because remember, whatever is inside of here could be 6. It could also be negative 6, because the absolute value of negative 6 would give you 6. So we're going to get 2 answers to this one too, also. I got 7/3 on that side, and negative 5/3 on this side. What do you think? You don't, because there's no chance of getting it. I mean, checking is a good idea to see if you made a mistake, but there's no extraneous roots in the problem. It's always a good idea to check, just to make sure you didn't make an arithmetic mistake or something like that. Wait a minute, does yours go right to number 11?
Yeah.
Okay, there appears to be a page missing. Let's see, did I stick it in somewhere else? Well, I guess I'll have to find that missing page. I didn't notice that till just now.
So we don't graph, or not graph, I mean put these on like a line.
You absolutely can. It is not an inequality. Inequalities we always put on the number line to shade. It does not appear that I stuck it anywhere else, so I'll find that missing page and get it to you. I have no idea where it is. I'll find it. But anyhow, let's go to the next one we have, which is number 11. We're going to graph this thing. All right, so let's look at it. What shape is it going to be?
Parabola.
It's going to be a parabola. And what do we know? What do we know about the parabola? It's going to open down. Parabolas are U shapes, but this U is actually down because there's a negative in front of it. Can you tell where the vertex or the turning point is? At 3, 1. Remember all that work we did back in the beginning of the year. When you have an x minus 3 inside the parentheses, it shifts you 3 units to the right, and a plus 1 on the end takes you up 1. So you have a vertex at 3, 1, and a parabola opening down, and that's all you have to do. I think, I can't swear by it, remember I'm old, but I think that's a multiple choice question also. So I think I've just drawn some graphs and you pick the one that looks like that. So you gotta have the vertex in the right spot and the opening the right way. That's easy. How about 12? Find the vertex. Now you found the vertex of that one very easily. You found the vertex of that super simple. how do you find the vertex of something like this? Anybody remember?
Put it in vertex form.
One option is put it in vertex form. What's a faster option? Negative b over 2a. Remember, negative b over 2a gives you the x-coordinate of the vertex. This is actually the axis of symmetry, but it's the x-axis, or the x-coordinate of the vertex, too. So for our problem, negative b over 2a would be 2. So your x-coordinate is 2. And then how do we find the other coordinate? Plug it back in the original. So 3 times 4 minus 12 times 2 plus 4. So 12 minus 24 plus 4.
Negative 8.
Yeah, negative 12 plus 4, so that'd be negative 8. So 2 negative 8 is the vertex. Now, Jalen suggested or said one option would be to put the equation into this form. You can do that. It takes longer, involves completing the square, remember? Vaguely. This is always faster. So I would recommend we just do that, negative b over 2a. You okay? Write the equation that would result if you applied the following transformations to y equals x squared. So what that means is this started out as y equals x squared. But we shifted it 3 units to the right by doing that. We turned it upside down and we lifted it up 1. So now you're going to make an equation that looks like that, doing these things. So, okay, y equals. All right, what about a horizontal shift to the left? Emma?
It would be plus 2.
In the parentheses with the x, right? Doesn't that shift us to the left? And it's squared because this is my baseline equation I'm starting with. Okay, now wait a second. We're shifted left, right? All right, now a vertical stretch by a factor of 3. So in other words, we want to make this thing 3 times as tall. Malcolm.
Did you put it one number 3, or is it negative?
You're thinking about all those things. You're right, but it's not 1 over 3. It is 3. This number right here multiplies the height. So it's a vertical stretch. A vertical stretch. Multiplies the height. Makes the height taller. To do that, you always put the multiplier out in front of the problem. All right, that makes it 3 times as tall. If we put a 1/3 out there, Malcolm, it would actually make it shorter. And then a vertical shift up 1 unit. So I'm going to pick this equation up 1. Plus 1 on the end. Yep, that's it. So you have taken it 2 units to the left. You've made it 3 times as tall, and you've picked it up 1. Oh, fond memories. Number 14, use interval notation to list the intervals where the function is increasing. So let's stop and remember what increasing means. Alright, increasing means that we are, as we move left to right, our pencil's going up. So remember back when we were looking at the cubing function and we described it as an increasing function? But when we looked at the absolute value function, it was decreasing for part of the time and increasing for part of the time. Well, that's what this one's doing. I am only interested in the increasing parts. So just kind of trace over it. When does your pencil start going up? Right here?
Mm-hmm.
And isn't it still going up?
Yeah.
Not here, but here. So the purple parts are the parts where my pencil is going up, increasing. We could have the same question decreasing, only then our pencil would be coming down. So what are the intervals? We're moving left to right. So we start going up at x equals -3. And we stop going up when we get to x equals 1. Make a note, these are x values. You're doing x values. Which x values? Do you understand that the first x right here at -3, I start going
So
up?
they're both x's.
X's. These are the answer is going to be x's, always. So I start going up from -3 till I get to 1, and then I don't start going up again until I get to 3 to 4. That's where I am increasing. That's the interval that I am increasing.
What's that little sign in between?
Huh?
What's the little sign in between?
It's the U symbol, the or. We've used that a lot of times. That's the or symbol. Huh? When I get to x equals 1, I stop going up. These are extras. I'm looking left to right. So from here to here, I'm going up. And from here to here, I'm going up. From -3 to 1, and from 3 to 4, I'm going up. Where am I going down? What would be, these are the increasing intervals. What would be the decreasing intervals if we needed them? Where am I decreasing?
-4 to -3.
-4 to -3.
One to 3.
And 1 to 3, yep.
4 to 5.
And 4 to 5, yep. So those are my decreasing intervals. They weren't asked for in the question, but those are the decreasing ones. All right, we'll do one more. Number 15. Now I gotta find that missing page. Good grief. All right, so number 15. It doesn't say to graph it, but I'm going to because I think it helps us answer the questions. What's the first thing we do when we graph something like that? Put some dots on there, right? And the dots are going to go at 2 and at 4. Is that okay with everybody? What are those dots called? X-intercepts. So the first question says, find the x-intercepts. You already did, they're right there. Those are the x-intercepts. Where do they come from? The factors. So assuming your problem is already factored for you, you got them right there. Now, let's not look at the rest of the questions for a minute. Let's see what we remember. This is a what degree? How many x's do I have here?
3.
3. And x cubes start down and end up, right? So I know I'm starting down here somewhere. Now when I get to that point, do you remember what my choices are? Go through, bounce off, or squiggle. Well, that point came from here. What am I going to do?
Bounce off.
It came from
It
here.
goes through.
You're gonna go through it. When do I bounce off?
There.
Right there, because that one is a square. Right? So, question C. At what point is the curve tangent to the x-axis? Right here. Tangent means bounces off. It's a tangent point. It bounces off. So the answer to C is 4, 0. Now, what about the y-intercept? I didn't have you graph that a whole lot, but you know how to find a y-intercept. If we are finding a y-intercept, doesn't x have to be 0? I know we talked about that whatever intercept you're finding, the other letter is 0. So if I want a y-intercept, I'm going to let x be 0. And if I let x be 0, this one's -2, and this one would be 16. So what's my y-intercept? -32. So 0, -32. To find a y-intercept for any equation of any kind, lines, circles, whatever, to find a y-intercept, we let x be 0. Okay? Now, I'm going to give you,